Hello everyone, welcome back to this YouTube channel. I hope everyone is doing great. Today I'm back with another physics question from Cambridge Physics A Level 9702. This is from October-November 2022, variant 202. So this is actually paper 2. Let's begin with question 3. State what is meant by the center of gravity of an object. This is the normal, typical definition that you should know before exam. So the answer is actually a point where the weight, actually you must say all the weight, all is very important, all the weight of an object is considered to act. Okay, just nice, got your 1 mark already. So make sure you know your definition before going to exam. It's very important. Don't lose mark for this type of questions, okay? Definition are your key marks question. Must score. Okay. Now B. A uniform beam AB is attached by a frictionless hinge. Okay, and it's a uniform beam to a vertical wall at NA. That means it's at here. The beam is held so that it is horizontal by a metal wire CD. Alright? Okay. The beam is of length 0.96 meter and weight of 23 Newton. A block of weight W rests on the beam at a distance 0.2 meter from NB. Where is B? Oh, this is B here. Okay, 0.2 meter from NB. Okay. The wire is attached to the beam at point D, which is a distance 0.4 meter from NB. The wire is attached at point D, which is 0.4 meter from B. Okay, nice. The wire exerts a force on the beam of 45 Newton, this is the one, at an angle of 37 degrees to the horizontal. The beam is in equilibrium. This is a very important point. Equilibrium. Usually, most of the question I've seen is usually the case will be it will be in equilibrium. Yeah, but that doesn't mean you shouldn't read the question. You must read. You never know when they will change the fact that they want it to be not equilibrium. So be aware. Okay, let's begin with question 1. Calculate the vertical component of the force exerted by the wire on the beam. They want the vertical component. Okay. This is our vertical component, and this would be 45 sine 37 degrees. Right? And this is 45 cos 37 degrees. How do I know that? Okay, let me draw for you. Okay, imagine this is the tension is here, right? 45. So this is ideally your vertical. Oops, this is ideally your vertical, and this is basically your horizontal, right? And 45 is basically your resultant force, if you want to see it that way. So what is this? This is hypotenuse. This is the adjacent, right? So you want to know what is this one? That is opposite. So 45 sine 37. Because you want to know what is the opposite side. You want to know what is the adjacent side? This side is 45 cos 37. Okay. If you can't see it that way also, no problem. Sine 37 is opposite over hypotenuse. In this case, which is your opposite? That is the one that we are trying to find. I'll just put it as x, okay? Hypotenuse is 45. So, what will you get? You get x to be equal to 45 sine 37, which is the same. This is another approach you can use. Same goes to cos. Cos 37 equals to adjacent over hypotenuse, right? So cos 37, your adjacent, I'm just going to make it as y, for example. Hypotenuse is 45. So what is your y? Your y is 45 cos 37. That is how you calculate. In this case, they want the vertical component. So our vertical component in this case is 45 sine 37. 45 sine. Remember to write your, okay, I know 45 sine 37, you might just type on your calculator and you get the answer, but working is very important. It's very crucial. So make sure you write everything. And make sure your calculator is in degrees and not radian. Because if your calculator is in radian, you might get a negative answer for this. So make sure it's in degree. So this is 27.08. You can leave your answer minimum 2 significant figures or 3 significant figures. I'm going to leave it to 2 here. So 27 Newton. The answer is 27. You can put 27.1 also, no worries. Minimum is 2 significant figures. Okay, make sure you have 2. By taking moments about A, calculate the weight of the block. Okay. So they want us to take the moment at this point and they want us to calculate the weight. Okay. Since it is in equilibrium, we can show that since it's in equilibrium, the sum of forces in anti-clockwise is equal to the sum of forces clockwise, right? Because it's in equilibrium. So let's see. This one is moving this way, so it is anti-clockwise. This weight of the rod is actually, okay, it's not rod, it's actually beam. It's actually beam. It's moving clockwise. The weight of the block is also moving clockwise. Okay, so now let's calculate it. Anti-clockwise, we have 145 sine 37 degrees. Make sure your angle, write the right angle. Do not accidentally write 35 degrees or what. Make sure be aware of what you are writing. Okay, to avoid all these careless mistakes. Okay, 45 sine 37. Now, we know moment, the formula is F times the perpendicular distance. X, let's denote that as perpendicular distance. So this is 45 sine 37. Your perpendicular distance from A is actually 0.56. Okay? 0.56. How about clockwise? 23 Newton is the weight of the beam. What is the perpendicular distance? The perpendicular distance is actually half of the distance of the rod. Why? Because the weight is usually acting right in the middle of the beam. Right in the middle, right? So 23 Newton is right in the middle. So what is half of the distance? Do not take 0.56 divide 2. It is not. They already said the beam is 0.96. So this whole thing is 0.96. That means half of the beam is 0.96 divided by 2, which will give you 0.48. Please take the correct value. They already say 0.96 is the whole thing. 0.56 is just here to here. It's not the entire beam. So do not take the wrong value, okay? 0.48. Plus, clockwise, we have another one. Okay, let me erase this here. Okay. We have another one here. This is the one that we're trying to find, the weight. The weight, what is your distance? 0.56 plus 0.2 from A. Why am I taking from A? Because they asked to take moments about A. You need to see which side or which hinge the question is asking you to take. So in this case, about A, that is why I'm seeing the distance from A. The perpendicular distance is 0.56 plus 0.2. So we can straight type out like 0.56 plus 0.2. It gives you 0.76. I'll write a side note here. This is 0.56 plus 0.2 so that you know where I got the value. Okay, now let's calculate. 45 sine 37 times 0.56. This gives you 15.1657. When you are in the process of calculating, try to leave your answers in 3 or 4 significant figures. When it's a final answer, then you do it minimum to 2 yourself. Okay? This is to ensure accuracy throughout your calculation. 23 times 0.48, 11.04 plus 0.76 W. Okay, so now this is just algebra. 0.04, you minus that, you will get 4.1167 equals to 0.76 W. Okay, what is your W? The W is 5.417, which is basically to two significant figures, it's 5.4. So this is your answer. 5.4 newtons. Okay. So, what is the conclusion from this question? Make sure you know which distance are you taking. Be aware of your distance, whether it is 0.56, whether it is 0.2, and which moment or which hinge are you taking as a moment. Very important. Okay. Done with Roman 2. Just nice. You have obtained your 1 mark, you have obtained your 3 mark already. Okay. The hinge exerts a force on the beam at NA. Hinge exerts a force on the beam at NA. Okay. That means the hinge is exerting a force this way. Okay, that is not where the hinge is. Wait. Okay, here. Then calculate the horizontal component of this force. Okay. As far as we are concerned, the beam is in equilibrium. That means the force acting here is equal to the force acting here. This one is equals to this. Am I right? Why? Because it's in equilibrium. If it's not in equilibrium, you cannot deduce this conclusion. I'm saying this because it's in equilibrium. So since it's in equilibrium, left and right forces will give you the same. So what are the forces acting in this direction? If you see, we have a force here. 45 cos 37. That is our horizontal force. There's no other horizontal force here, right? So that is our horizontal component. 45 cos 37 degrees. 45 cos 37, it gives you 35.9. Basically 36 Newton to two significant figures. Okay, nice. You get a 1 mark. Moving on. The block is now placed closer to point D on the beam. State whether this change will increase, decrease, or have no effect on the tension in the wire. Okay, let's look at the question. Okay, let's erase all the unwanted stuff since we have done our calculations. Okay, now imagine the block is moving closer to point D, right? Okay, let's put our block at the point D. Because they say closer to point D, let's just assume that it's at the point D here. Okay, you see it can be anywhere. You can even put it here, you can even put it here, as long as it's closer to point D. So let's say I'm going to put D there. Okay, whether it will increase or decrease or have no effect on the tension. So basically they're asking whether it will change this value or not. This 45 Newton, whether it will change or not. Okay, let's do a simple calculation to know whether they actually change it or not. Okay, first of all, same concept, it's in equilibrium still. Sum of forces anti-clockwise equals to sum of forces clockwise. ACW is anti-clockwise, CW is clockwise. Okay, you have a force here. This is going anti-clockwise, this is clockwise, and this is clockwise. Okay, so now our anti-clockwise is 45. No, not 45. That is what we're trying to find. Let's put it as x. Sine 37 degrees. Your distance is 0.56. Okay. Clockwise, 23 Newton, 0.48, because it's the same value, plus, what was your weight just now? 5.4. 5.4, and your distance was 0.76. But it was 0.76. Now we have already changed the distance, right? Because we are bringing it closer to D. So now I'm going to take this value. Be careful. When you want to calculate, be careful what distance are you taking. Your block is now here. Am I right? So your distance is supposed to be here, 0.5. Estimate distance 0.56. If your block is here, then maybe it's 0.6 perhaps. take the new distance. Do not go and accidentally take 0.76. Be careful. Don't do these mistakes. Must be very aware when it comes to calculation. Okay. Now, let's calculate our right hand side first, since we have all the values there. 0.56. Okay. What we get? 14.064. Okay, then 0.56 times sine 37 gives you 0.337x. Okay, what is our x? Just simple algebra. Divide. I will get 41.7, which basically gives me 42 Newton. So, does it increase or decrease? Initially, it was 45. Now, it's 42 Newton. That means it has decreased. So, your conclusion, what happens to the tension? It decreases. Usually this type of question, sometimes for you to see it just like that, it might be challenging. So I would suggest you do calculation like this. I am used to doing calculation like this because I practice myself to calculate, because I cannot see like that. I need to calculate and see the value to know whether it's increasing or decreasing. In physics, anything can be done using mathematical calculation. So when calculation is possible, proceed to do it. Okay. Alright, we're down to the last question. The stress in the wire is 5.3 times 10 to the power 7 Pascal. The wire is now replaced by a second wire that has a radius which is 3 times greater than the original wire. The tension in the wire is unchanged. Calculate the stress in the second wire. Okay, this one we can use ratio. Ratio method is actually very easy when it comes to this type of question. We know stress is equals to force over cross-sectional area. Am I right? So, and we know the stress is from this, it's inversely proportional to the cross-sectional area. Right? So, wire is actually, the area of the wire is actually pi r square. Right? Okay. So, using ratio, let's do this. Stress of the new one over stress of the old one equals to, since it's inversely proportional, your cross-sectional area of old should be up, the new one should be down. This is the ratio method. That is very useful. First, you need to know what is the relationship. Then, you form the ratio. If it's inversely proportional, it must be in the opposite direction. You cannot have in the same side. You must go down because it's inversely proportional. Okay. Now, what is the new one? That is what we're trying to find. Am I right? Okay. The old one is 5.3 times 10 to the power 7. What is the old area? Pi r square. Right? New one has a radius that is 3 times greater. That means area of new one is pi 3r square. Make sure you square outside. Do not 3 square, then you forgot to square your r. Very dangerous. Pi 9r square. Square the entire thing in the bracket, which will definitely give you 9r square pi. So that is your new area, 9r square pi. Pi r square can cut. So your new is equals to, this is basically 1 over 9 times 5.3 times 10 to the power 7. Which will gives you 5.3 times 10 to the power of 7 times 1 over 9. You will get 5.89 times 10 to the power of 6 times 10 to the power of 6 Pascal. In two significant figure, it's 5.9 times 10 to the power 6. There you go. When it comes to this type of question, where they give you a value, stress value and they give you the area, and now they want you to find a new value if the area changes or if let's say the force changes. You use ratio method. But when it comes to ratio method, usually one of it has to be constant. In this case, they already say the tension is unchanged, so this will not change. Ratio method is very useful and very fast as well, so try using this method. Okay, there you go, got 2 marks. So that's about it for this question. Very interesting question. They cover moments and it covers something about stress and tension. My advice to you is, when you're doing calculation, be careful. Be very, very, very careful so that you don't make the careless mistake. Okay, so that's all for today's video. I'll see you in the next video. Have a nice day ahead. And if you have any questions that you want me to try, please let me know in the comments. I'll try my best to solve it. And please don't forget to subscribe, like and share this video. Thank you.